Hello everyone, today we will explain sample space, which is in the subject of probability. And the first thing, we will give an introduction about what is the sample space. Sample space is a set of all possible expected outcomes or the results after performing an experiment. For an example, we'll get a small and a simple experiment. First experiment is when a tossing of a coin. So the question is like this: tossing of a coin experiment. Okay. So when we tossing a coin, we have what? We have the tail and the head, right? So we have only two. The total of the sample spaces is 2. The sample space, as we said, it is the possible expected outcomes. Maybe it will come head, maybe it will come tails. The sample space is the total of that. Sample space is C. Sample space for the first experiment. This is the sample space experiment. It will come. We open the braces and we write head or a tail. This is the first experiment, and the number or the total of the sample space is what? Is 2, head or tail. And total of space is 2. This is a simple experiment about sample space. The second experiment is if we tossing 2 coins. Tossing or throwing 2 coins of 2 coins. Experiment. Okay, so this is the sample space. And here we have 2 coins, so the sample space will be like this. So you get to know how to get the total of that sample space. You have to write 2 coins like this. Open braces. This is the first coin. Multiply by what? By the second one. And now we have to multiply the first one by the second one. How? First head is with the first one and the second one. We will get, maybe in the experiment when we throw 2 coins, maybe when we get head and head together, maybe we'll get head and tail, maybe we'll get tail and head, maybe we'll get tail and tail 2 times. So the number of the outcomes is like this: S equal to, open the braces, first one is what? Head and head. So we write like this: H head, both 2 head. Second one is head with what? With tail. HT. Now we go to the next one with tail, and we multiple with the second one is tail with what? Tail with head. So TH. Second one with last one, tail with tail. So TT. Close the braces, and that's it. Now the number of, or the total of the sample space is what? How many there are? 1, 2, 3, 4. So 4. This is easy. Third experiment, if we throw 3 coins or tossing of 3 coins, okay? tossing of 3 coins experiment. The sample space, how to calculate it? This is the sample space. We have 3 coins. This is the first coins. This is the second coins. This is the third coins. Multiply and multiply. So the easy one to multiply the sample space of the 3 coins. First one, we have to calculate this one, the first coin with the second coin, and we will get this result as we calculated in the second experiment. So you have to write this one. This is the total of what? Of this one and this one. So the symbol will be like this: H T TH TT, close the braces, and multiply by what? By the third coins. Now we multiply this one by this one, the total of the 2 coins with the third coins, and it will be the final answer. So first one is head with what? With the first of the total of 2 coins. So this one, this is the first one, 3 heads, 3H. Second one is with the first one, H T. With the third one, H T H. With the fourth one, H T T. Now the second one, tail, with the total of the 2 coins, T H H, T H H, T H T, T T H, and last one is double 3 times of tail, T T T, and close the braces. And this is the expected and the possible outcomes or the results of throwing 3 coins. And the number of total sample space is 1, 2, 3, 4, 5, 6, 7, 8. So total of S is equal to 8. Now if we get an experiment of what? Of throwing a dice, or a die as we call it. So this is the question. This is an experiment of throwing of 2 dice experiment. Okay, how to solve it? The sample space is what? This is the sample space. What we are getting, or the expected outcomes, if we throw 2 dice. If we throw a 1 dice, we will get what? We will get 1, maybe 2, maybe 3, maybe 4, maybe 5, maybe 6. This is what we get in throwing an 1 dice. And if we throw 2 dice, so we multiply it by what? 1, 2, 3, 4, the other one, 6. Okay. Now, how to write it? First one multiplied by the second one, as we show in the first question, like this. So S is equal to, we have to multiply this one by all of this, and second one by all of this, third one by the second dice, fourth one with all of the second dice and extra. We have to put like this. So 1 with what? With 1. With the other one. 1 with the second one of the next dice. 1 with 2. 1 with 3. 1 with 4. 1 with 5. 1 with 6. And we go to the next one. 2 with 1. 2 with 2. 2 multiplied by 3. And so like this. You have to do like this. Simple, easy. Simple and easy experiment. So 2 and 5. 2 and 6. We go to the third one with the total of the another dice, like this. 3 with 1, 3 with 2. Maybe it will come like this. Maybe the outcomes or the result will come like this, 3 and 3. If we throw it, maybe it will come 3 with 4, 3 with 5, 3 with 6, 4 with 1, 4 with 2, 4 with 3, 4 with 4, 4 with 5, 4 with 6, 5 with 1, 5 with 2, 5 with 3, 5 with 4, 5 with 5, 5 with 6, last one, 6 with 1, 6 with 2, 6 with 3, 6 with 4, 6 with 5, last one, 6 with 6, and close the braces. Okay, so how many we have? The total of the sample space of throwing of total the dice, okay, of that. NS is equal to how many we have? 1, 2, 3, 4, 5, 6, 7, 8 is going to be like 56. Okay, if we calculate it, we'll get this number. How to know? 6 multiplied by 6 is 56. This is an easy explanation of sample space. So we need the sample space to know the experiment so we can do the probability. Okay, now we go to the probability, and the formula is probability is, or this is the probability of an event. I'll explain you what mean of the event. Is equal to what? Is equal to the, we write here so we get a good space. The number of outcomes where the event occurs here. Okay, divided by what? By the total number of possible outcomes. Okay. An easy shortcut. This is the probability of event. We write it like this: B, A. A is what? Is an event equal to number of what? Of the event divided by what? By the total of sample space of the possible outcomes. Probability always lies between 0 and 1. It cannot be and never be negative. Negative, it means like less than 0, and also cannot be a greater than 1. It comes between 1 and 0, 0 and 1. Okay, I'll give you a question about the probability now. So this is a question about probability, and the question is: find the probability of obtaining an odd number in the roll of an unbased dice. Okay, first of all, we write the sample space. We want to know the sample space, so we write sample space is what? Is the expected outcomes or the result of the possibility of throwing a dice. So the question is to find the probability of obtaining only the odd number. So the event is what? The event is getting all odd numbers. The sample space is what? S, open the braces, is 1, 2, 3, 4, 5, 6, as we explained before, and the number or the total of that one of the symbol is what? 6. 1, 2, 3, 4, 5, 6. So let A is the event of the question here. The event of getting what? The question, what the question need from us? The probability of what? Probability of what? Of getting all odd number. Okay, so A is equal to what? To the odd number. This is the sample space. Where is the odd number? 1, 3, 5. So we write like this. Open the braces. 1, 3, and 5. We have only 1, 3, 5 odd numbers. So we write it like this. So the event of getting all odd numbers is 1, 3, 5. So the probability of an event of getting an odd number is BA, is the probability of an event, is equal to what? The formula is what? As I show you here, the formula is probability of an event is the total or the numbers of outcomes where the event occurs. This one, 1, 3. Here it is number of A is equal to 3. So we have only 3. Okay, numbers of event divided by what? By the number or the total number of possible outcomes, and the total of possible outcomes is 6. Number of sample space. So number of A, the event is 3. We write it like this: 3 divided by what? By total number of possible outcomes is 6, and is equal to 1.2. which means the probability of obtaining an odd numbers is equal to 1 divided by 2, which means 0.5, the half. So this is the answer of this question, the probability of obtaining an odd number. We will get half. 0.5 or 1 divided by 2 is the same answer, and we'll see you in the next video. We will explain another probability and examples of probability, and please don't forget to like and subscribe. Thank you so much. Bye.